these are the step-by-step answers for the slope fields practice test. I am a bit congested, so my voice may sound a little bit different. Let's get started. So let y equals f of x be the particular solution to the differential equation dy dx equals 1 plus y over 4 minus x squared. It says you may use the graph below for problems 1 to 6, but it is not required. So what this is saying is that this does not give you, if this were going to be on a test, you did not have to fill this out for points. But I do recommend you fill this out when it is given to you, so you may use this as a reference graph to solve your problems below. So what I want to do first is solve individually for each point. Or find the slope for each point on this graph. So there are 6 dots, meaning we're going to find 6 different slopes. So this first one is going to be -1, +2. I'm going to use the color blue for that. So it's going to be -1. Use the pen. -1, +2. Alright, so now we're going to plug it in. So it's going to be 1 plus 2 over 4 minus x squared, which is -1 squared. So it's going to be 3 over 4 minus 1. Which is going to be 3 over 3, which is 1. So it should be a slope of 1. It should look something like that. So let's do -1, +1. Okay, so we're going to plug that in. So it's going to be 1 plus y, which is 1 plus 1 over 4 minus -1 squared, which is going to be 2 over 4 minus 1. It's going to be 2/3. Your slope for this should be looking like this. Okay, let's do 0, 2. This guy. Okay, so we're going to do 1 plus y, which is going to be 2, over 4 minus x squared. So it's going to be 4 minus 0 squared. That's going to be 3. It's going to be 4. It's 3/4. So your graph should look a little bit something like this. Okay? And then, oh wait, this is the wrong one. There you go. It looks something like that. And then the third slope would be 0, 1. So it would look something like this. 0, 1. 1 plus y, which is 2, over 4 minus 0 squared, which is 2 over 4, which is equal to 1/2. Then your slope should look something like this. Let's make it a little bit more like that. Okay. And then I'm gonna change the color. Let's do gray. Okay. Now we're gonna do this point. We're gonna do 1. No, we're gonna do 1, 2. Okay. 1 plus y, 1 plus 2 over 4 minus 1 squared. 1 plus 2 is 3. 4 minus 1 squared is just 4 minus 1. So it's 4 minus 1 is 3. It's going to be a slope of 1. Did I do it right? 1 plus 2 is 3. Yeah, 4 minus 6 squared. Yeah. So it's 3 over 3, which is 1. So you're going to have a slope of 1 for 1, 2. It should look something like that. Okay. And then I'm going to use black for this one. dy dx, which is 1 plus 1 over 4 minus 1 squared, which is 2 over 4 minus 1 squared is just 4 minus 1. 4 minus 1 is 3, so it's going to be 2/3. It should look something like this. No, not that good. Like that. Okay. Let's move on to the next slope. Let's do a little salmon color. We're going to do the bottom 6. Here we go. So it's going to be, we're going to start with this one. -1, -1. So let's do that. So it's going to be 1 plus y, 1 plus -1 over 4 minus -1 squared. 1 plus -1 is just 0. 4 minus -1 squared is just 4 minus 1, which is just 0 over 3, which is just 0. So you're going to have a horizontal line here. And then let's change that to orange color. And then let's work on 0, -1. Plus -1 is just 0. Then 4 minus 0 squared is just 4, which just gives us 0. There you go. Let's change color. Let's give it a little light blue. Okay. Then we're gonna do 1 -1. 1 plus -1. 1 plus -1 is just 0. 4 minus 1 squared is just 4 minus 1. This is just 3, which just gives us 0. So you're going to have a horizontal asymptote at y equals 1. Let's give it a purple color. Let's do the last 3. So it's -1, 2. -1, -2. Plus -2 just gives us -1 over 4 minus -1 squared is just 4 minus 1, so it's just -1/3. Your slope should look something like a narrow. I don't like that. It's not supposed to be curvy. There you go. And then let's give this a little brown color. Let's do 0, -2. Oh, it's not even dark. Okay. 0, -2. 1 plus -2 over 4 minus 0 squared, which is 1 plus -2 is just -1, and 4 minus 0 squared is just 4, so it's -1/4. So it should be really narrow. I would say something like that, more narrow than that, hopefully. Yeah. Let's give it this color. Let's give it this lime green color. Okay, so it's gonna be 1, -2. Okay. Equals, what is 1? 1 plus y. 1 plus -2 over 4 minus 1 squared. What's 1 plus -2? It's going to be -1. 4 minus 1 squared is 4. something like this, it doesn't have to be super specific. As long as you make it obvious, you know what you're doing, and you can distinguish. The AP graders can distinguish the difference between your narrow and steep lines. Okay, so let's go to number 1. What values of y does f of x have a horizontal tangent? So if you guys remember from pre-calc or algebra 2, there is always going to be a horizontal tangent when why is my pencil not working? When y equals 0, or when the slope is equal to 0, right? So 1 dy dx is equal to 0. Why is it canceling everything? Why is it changing color? dy dx equals 0. So it's going to be, and as you know, dy dx can be rewritten as 1 plus y over 4 minus x squared is equal to 0. Can we just say that this is going to be 0 over 1, right? So here, horizontal tangent is when you have a numerator of 0, because if you were to set the denominator equal to 0, anything over 0 would give you an undefined slope, and an undefined slope would look, or an undefined slope would give you this sort of asymptote, which is not what we're looking for. That's number 2. We're looking for a horizontal tangent. We're looking for something like this. Okay. So it's going to be 1 plus y equals 0 minus 1, which gives you y equals negative 1. You could not have done the algebra, and you could have looked at the graph here, because isn't there a horizontal tangent because these slopes are 0? Yeah, you did not have to do all that work. You could have used the graph, which saves you a lot of time. So that concludes question 1. What values of x does f of x have a horizontal tangent? So you have a vertical tangent when your slope is undefined. So dy dx equals undefined, and that happens when your denominator is equal to 0, not your numerator. So ignore the numerator for this question. From this question, for number 1, you get to ignore the denominator. So yeah, we're going to do 4 minus x squared equals 0. So let's put an arrow there and show the work. So it's 4 minus x squared equals 0. Let's just algebraically solve it. So it's negative x squared equals negative 4, which that's just going to be x squared equals 4 square root. Those cancel out. X equals plus or minus 2. That concludes question number 2. Yeah. If x, for number 3, if x is greater than 2, for what values of y will dy dx be negative? So, if x is greater than 2, then dy dx is less than 0, meaning yeah. So let me just look at the solutions and try to analyze what I'm dealing with here. So yeah. Okay. I figured it out. So we're gonna deal with the numerator only again. So it's gonna be 4 minus x squared is less than 0. 1 plus y why that is because dy dx is less than 0. It's because why is 4 minus x squared less than 0? Maybe it's because it's in the denominator. Yeah. So yeah, they changed it to a negative sign at the end. Okay. Yeah. So dy dx is equal to 1 plus y. Let's leave that numerator alone. Since this is going to be less than 0, that's going to be negative. So let's leave it like that, which is less than 0. And then divided by negative, that's just going to give you you can just use that negative and use that to switch the sign. So it's going to be 1 plus y is greater than 0 because of that dividing by negatives. Because remember, when you dealt with inequalities back in algebra 1, when you divided by negatives, you always switch the sign whenever you divide by negative numbers. So it's 1 plus y equals 0 minus 1. Y is greater than negative 1. Yeah, this number 3 was a little bit confusing, but oh, now I know why it's gonna be y. For what values of y? Because I know why we made this negative now. It's because we're dealing with y. We're not taking x into consideration in this problem, so we're gonna replace that with negative because we were trying to make this negative. I hope that made the problem more clear. Okay. Describe all points where x is not equal to plus or minus 2 in the xy plane for which dy dx equals 2. So it's going to be 1 plus y over 4 minus x squared equals 2, because this is, let's circle that in a different color. This is dy dx. Okay? Then I'm just going to move this up. So it's going to be 1 plus y. We're going to multiply both sides by 4 plus x squared. Oh, it's minus x squared. Boom, boom. 4 minus x squared. 1 plus y is 2 times 4 is going to be 8 minus 2x squared. We're going to isolate that y. So we're going to subtract 1. So y is going to be 7 minus 2x squared. Then there you go. It's asking for, so what this concludes question 4. What this question was basically asking you is that from all the points where x is not equal to plus or minus 2 in the xy plane, for the slope is equal to 2. So using this, this is a y equals mx plus b. This gives you like a linear. That gives you a slope of 2. Okay, so now this is a separation of variables problem, or the 4-step problem that Ms. De Leon and Mr. Rodriguez has been teaching you guys. So what I do first is write down the whole thing. Dy dx is equal to, what is this again? 2x plus 1 over y squared. Okay. I don't like this pencil. Okay. So now what we're gonna do first is bring the y's to the left and bring the x's to the right. So what I'm going to do first is multiply both sides by dx. I prefer doing this step by step so you guys don't get confused. So it's going to be dy equals 2x plus 1. Why is it erasing? Y squared dx. Now we're going to multiply both sides by y squared. So it's going to be y squared dy equals 2x plus 1. So this whole chunk was, I don't like that. Let's do it. This is step 1. Separate. Okay, so now we're gonna have y2 dy equals 2x plus 1. Do not forget to put your dy's and dx's. These are very handy for future problems, so do not leave these out. These are very important. So now the second step is to integrate. So let's start with this y squared dy. So using the anti-power rule, you're gonna add 1, that makes 3, divide by that new power, so it's gonna be y cubed over 3 equals, why did I have a steep triangle there? I don't know why. Okay, y cubed over 3 equals 2x plus 1. What you could do, this is like a sum rule integral, 2x dx plus 1 dx, which gives you, what is the antiderivative of 2x? This is anti-power rule slash memorized integral, which is going to be x squared plus, I should have color coded this, 1 dx, the integral of 1 dx is just x, plus c. The reason why I did not add plus c on the y side is because we're going to try to solve for y at the end, which if you added a c there, that would mess up the whole problem. You only needed to add a c. When it's a separation of variables problem, you only need to do the plus c on the x's side. So yeah, we finished integrating it. So this is step 2, complete. Integrate. Okay. Yeah. And then step 3, find your IC, which is your initial condition. Your initial condition is 2, 0. Okay. So we're just gonna plug in the values here. So all your variables here. So what is your y? Your y is going to be 0, which doesn't really do anything, which is going to be, and your x is going to be 2 plus 2 squared plus 2. So it's going to be 0 equals 4 plus 2 plus c. Let's put an arrow there. 0 equals 6 plus c. You want to find your c, so you're going to isolate the c. 0 minus 6 is just negative 6, and that equals c. And then there you go. Step 3, that was find IC. Okay, now for step 4, that is find y, which is your last step in this problem. So what you're gonna do is before you did everything to find your IC, you're going to take this entire equation here. So your y cubed over 3 equals x squared plus x plus c. You're gonna put that back up. So it's gonna be y cubed over 3 equals x squared plus x. And since we found our c, which was negative 6, we're gonna do that. So now we're gonna multiply both sides by 3. Actually, I'm not gonna use red. Let's use a better color. Let's use this. 3. Those cancel out. And then it's gonna be y cubed equals 3x squared plus 3x minus 18, which we just foiled. And then now we're gonna find the cube root. We're gonna isolate that y. that cancels out, so it's going to be y equals the cube root of 3x squared plus 3x minus 18. And that is your final answer for part 1 of your practice test, or problem 5 of your practice test. Alright, problems 6 to 11. Solutions to differential equation with slope dy dx for x cubed y squared also satisfy the second derivative of slope dy dx equals 4x squared y squared foiling 3 plus x 8x cubed y. Let y of f equals f of x be a particular solution to the differential equation dy dx equals 4x cubed y squared with your IC of, or initial condition of, f of 1 equals negative 1. The equation of the tangent line to the graph at y equals f of x at 1 comma negative 1 is. So this is we're trying to find y equals mx plus b. That's going to be your tangent line, if that's how it's supposed to be formatted. You could do y minus y1 equals mx minus x1. Both formulas are accepted on the AP exam. I think they prefer to use point slope form over slope intercept form, but you won't get deducted points if you use slope intercept. So to find our stuff, we need to find our x, y, m, and b. We already found our x and y. I shouldn't be using green. That's going to be, forget about it. X is going to be 1. Y equals negative 1. M, that's your slope, and b. So y equals f of x. So m is your slope, right? M is slope, which is dy dx, which is this 4x cubed y squared. Now we're going to evaluate that at x at 1 comma negative 1. Okay, so what we're going to do first, we're going to do 4 times 1 cubed times negative 1 squared. So it's going to be 4 times 1 times 1. Why is it not putting the dot? Okay, which just gives you 4. Your m is 4. Now you're going to plug everything in together, so it's going to be y. Let me create a borderline here. That way you guys don't get confused with the messy, disordered handwriting. So it's going to be y equals mx plus b again. We're going to plug everything in. So it's going to be y, what is y? Negative 1 equals, what is m? 4 times 1 plus b. So it's negative 1 equals 4 plus b. Subtract both sides by negative 4. Negative 1 minus 4 is negative 5. That's your b. And there you go. Now all you gotta do now, pardon me, is put it in y equals mx plus b, or y minus y1 over equals m over times x minus x1. So I will write you the answer in blue for this page, because I don't know why I wrote in green. Okay, so let's do it in y equals mx plus b first. So it's going to be y equals, what is your slope? 4x. Our b is negative. And then let's do it in y and point slope form. So it's going to be y minus negative 1, which is going to be y plus 1, equals m x minus x1. So it's going to be x minus 1. And then that is your answer. Let's highlight this one. either format is acceptable. I did not write that neatly. Okay, this concludes question 6. Now we're going to be on question 7. So using this we're going to find the approximation, because the squiggly line here, of f of 0.8. So we're going to be using y equals, no, I'm going to use green. Y equals 4x minus 5. Yeah. Y is equal to f of x, right? But in this point is f of 0.8, right? So now we're going to substitute that for y. So it's f of 0.8 equals 4. Since this is an f of x, you're going to replace that with x, which is 0.8 minus 5. And then what is 0.8 minus 5? 4 times 0.8 minus 5. 4 times 0.8 is 3.2 minus 5, which is just negative 1.8. And there you go. That concludes question 7. At 1, negative 1, the value of the second derivative of the slope is... Okay, so now we're going to evaluate this second derivative, this long derivative here. We're going to evaluate that at that value they gave us, that IC. Okay, so second derivative. Okay, d2y over dx squared. Oh, and if you guys are confused about this notation here, this is basically the derivative of the derivative, which is why it's the second derivative, right? Finding the derivative of the derivative of the derivative. So it's d, you're going to cross multiply, so it's d squared y dx. Why is it not doing that? Dx squared. Just wanted to show you guys what that meant, in case some of you guys were confused. I found that really helpful last year. Okay. Alright, back to solving this. We're going to evaluate this at the IC. 1 comma negative 1, which is going to be 4 times 1 squared times negative 1 squared. Let's separate that into a chunk for now, and then do that. 3 plus 8 times 1 cubed times negative 1. Yeah. Now I want to chunk these all together. After 4 times 1 squared, that's just going to give you 4. Times negative 1 squared is just 1. So it's going to be 4 times 1. That's just going to give you 4. Times 3 plus 8. 8 times 1 cubed. 3 plus 8 is just 11. 11 times negative 1 is just going to give you... Negative 1 is just negative 11. And... Wait. Did I do that right? 4. Oh, shoot. My bad. I did not apply PEMDAS correctly. That is my bad. Alright. There you go. Let's clean that up. So first, is going to be 8 times 1 cubed, which is just 8. 8 times negative 1 is just negative 8. 3 plus negative 8 is just negative 5. What is 4 times negative 5? That's just going to equal negative 20. And that is your second derivative. That is your answer. So does the tangent line at 1, negative 1 lie below or above f of x? So is your approximation greater or less than actual? So in other words, your approximation is your tangent line and your actual is your second derivative. Okay, so is your approximation, this is your approximation, or your tangent line, and this is your actual, which is your second derivative. Okay, is it greater? So is your approximation, is this greater than negative 20? Is negative 1.8 greater than 20? Yes. So does your tangent line lie below or above f of x? So if you're let me teach you a trick that really helped me master this problem here. If you have a concave up function, your thing is going to be an underestimate, which is less, because your tangent line is below your concave up curve. But if your curve is concave down, your tangent line lies above a concave down curve, meaning this is an overestimate because your tangent line is over or above your function, or a concave down function. Okay, so that's just a little trick that I wanted to introduce to you guys. So now you just gotta write this explanation down. So does your tangent line lie below or above? Since your approximation is greater, TL, tangent line, lies above f of x, which is a concave down curve. Okay. Yeah, because as you can see, your curve over here is negative, meaning it's gonna go down. It's gonna look something like that. If your curve were positive, if this answer were positive, it were positive 20 or positive 1.8, it would be an underestimate, meaning it will lie below the function of f of x. I hope you guys can make that connection easily. Okay. So, is the approximation for f of 0.8 greater, less than, or equal to the actual value of f of 0.8? So basically, is the tangent line greater than the second derivative? Is basically what it's asking for. Yes, it is greater than. Approximation is greater than actual value of f of 0.8. Yeah, you do not need to type a lengthy essay to write your answers on the AP exam. You could literally just write the exact sentence I was saying, and your AP graders will give you credit for that. Okay, so now we have a separation of variables problem again. So let's apply the first step. Step 1, separate. Okay, separate. So what I'm going to do first, I'm going to use blue this time so I can circle my answers in green. So it's dy dx equals 4x cubed y squared. We're gonna bring the x's to the right and bring our y's to the left. It's gonna look a little bit messy, but I'm gonna put it back up here. 1 over y squared dy equals equals 4x cubed dx. Okay. Now we're gonna integrate these. So there you go, integrate. What is the antiderivative of 1 over y squared? That is your memorized derivative. You should know that. That's just going to be negative 1 over y equals, remember that you don't need to put a plus c because we're dealing with y here, not x. We're going to deal with an anti-power rule. Just looking at this, it's just going to be x to the power of 4 plus c. Add 1 divided by the new power. So we integrated that. Now we're going to find IC. We're going to plug in that thing. So it's going to be 1 over negative 1 equals 1 to the power of 4 plus c. That's just going to give you 1 equals 1 plus c minus 1 minus 1. That's going to be 0 equals c. So your c doesn't have any value in this problem. So now let's find y. That is messy. Okay. Alright. So it's going to be negative 1 over y equals x to the power of 4. We can rewrite that as negative 1 over y equals negative... Oh, let me remove that negative. X to the power of 4. Negative. Because we swapped the negative. Now we can just isolate y by just reciprocating that. So it's going to be y equals negative 1 over x to the power of 4. And that is your final answer. This concludes question 11. On to the last one. If x is less than 7, then the absolute value of x minus 7 is equal to, since x is less than 7, x minus 7 is less than 0. Okay? So, since x is less than 7, x minus 7 is less than 0. Why? Because, for example, if you put, since 6 is less than 7, right? 6 minus 7 is less than 0 because 6 minus 7 is negative 1. And then if you put lower values, the negative values would just become greater, right? So it's going to be x, absolute value of x minus 7 equals negative of x minus 7. And yeah. Oh, okay, I get it. So basically, since that is your value, okay, yeah, since the absolute value of x minus 7 and your x minus 7 must be less than 0, your answer must come out positive-ish, I suppose, since we're dealing with this negative here. Since our answer is always going to be negative because x minus 7 is 0, we're going to have to put that negative outside so we can FOIL it. So now it's going to be negative x plus 7, which can be rewritten as 7 minus x. This is a tricky question that most people would most likely get wrong on this exam. It's kind of hard to explain it a little bit, even for me. But if you know your inequalities and how to solve for that and your properties of absolute value, you should be good here. Anyways, this concludes the slope fields practice test. Good luck on your exam on Wednesday. And if you have any questions, please let me know or ask Ms. De Leon and Mr. Rodriguez. Thank you.